Hello everyone, I am Ritika Zuzgar, Assistant Professor IT Department. In the course of machine learning, we started our second unit, that is regression. In today's lecture, we discuss about linear regression using the gradient descent. Okay, so here we can learn how the gradient descent algorithm works and the implementation of the gradient descent. Okay, so first we look at the linear regression. If then we define the loss function and we learn how the gradient descent algorithms works, and finally we will implement this gradient descent algorithm. Okay, so here in the linear regression, in statistics, the linear regression is a linear approach to modeling the relationship between dependent variables and one or more independent variables. So here let x be the independent variable and y be the dependent variable. So we will define a linear relationship between these two variables, that is independent variable and a dependent variable. So what is the equation for the linear regression? Y equal to mx plus c, where y is the dependent variables, x is the independent variables, m is our slope of the line and c is the y-intercept of a line, okay, or a coefficient of a line. So here y is our predicted value and x is our input variable, input value, okay. So this is the equation for a line that we can study in the high school, okay. So m is the slope of the line, c is the y-intercept, okay. So today we will use this equation to train our model with a given data set and predict the value of y for a given value of x. So our challenge today to determine the value of m and c, so such that the line of corresponding to those values is the best fitting line or giving the minimum error. Okay. So see here, the value of m and c are updated at each iteration to get the optimal solution. Okay. So see here, we have some data set in the blue dot, and we are drawing one line of best fit by using this linear regression equation y equal to mx plus c. Okay. So here we are changing the m and c at each iteration. So next is what is mean by loss function. For the gradient descent, by using linear regression, we required a loss function. Okay, so the loss function is the error in our predicted value of m and c. So our goal is to minimize this error to obtain the most accurate value of m and c. So we will use the mean squared error function to calculate the loss. Okay, so there are different steps are present. The step one is what? Find the difference between the actual y and the predicted y value. That is y equal to mx plus c for a given x. Okay. Find the difference between actual y and predicted y value for a given x. So, what is the difference? So, see here. So, first step is what? Difference between. Step one is what? Difference between the actual y and the predicted y value. So here y for the different input values yi minus y dash. ओके सो यहाँ पे मैं ऐसे यूज करती हूँ वाई आई माइनस वाई आई डैश. ओके सो दिस इज द डिफरेंस बिटवीन एक्चुअल y एंड द प्रेडिक्टेड y. सो यहाँ पे एक्चुअल y क्या होगा? where yi is equal to actual value फिर जैसे हमने अभी देखा था W1 को पॉप आउट करके हम W2
and
इंसर्ट करेंगे। हमारे पास स्टेट क्या रहेगी
yi dash
फंक्शन सभी को समझ में आया
is equal to predicted
that is
value.
also in like this transition.
Okay, so this is our step 1. Then the next is what? Our step 2 is square these differences. So हमें क्या करना है यहाँ पे, उसका स्क्वायर करना है. तो स्क्वायर क्या होगा यहाँ पे, yi minus yi dash स्क्वायर के लिए मैं so this is a step 2 and the next is what, our step 3, find the mean of the square for every value in x. so हर एक का हमें क्या करना है, mean find out करना है for every value of x.
union operation, right? Arithmetic or operation हम बोल सकते
So
हैं, correct?
we have n number of data set, का मीन हर एक के लिए. ओके, मीन मीन्स वो जितने नंबर ऑफ डेटा सेट है, मतलब पहले इसके एडिशन करके हमें क्या करना है, समेशन करके हमें क्या करना है, डिवाइडेड बाय n सो दैट वी गेट द मीन ऑफ स्क्वायर ऑफ एवरी वैल्यू इन x. सो समेशन ऑफ
transition function for this all operation
summation of
q1 a w1
I equal to
that means we have replaced a with the w1 and we are having q
0
comma
to n, starting from 0 to n. And here we have
q3 comma w that is
yi minus yi
w2
dash whole square.
अगर मैंने W3 पर चूज किया so I will have the Q3 state. Okay? Transfer ले लो transitions का.
Okay, yi minus yi dash whole square. Okay, so this is a step. Find the mean of the square of every value in x. So next step is the mean the square error equation. Okay, so this is a square equation and substitute the value of y I dash. So यहाँ पे देखो हमें क्या करना, y I dash की this means our predicted value जो है उसकी value print करनी है. So final equation become, see here, so 1 divided by n into summation of I equal to 0 to n in bracket yi जो हमारा एक्चुअल वैल्यू है एंड द प्रेडिक्टेड वैल्यू के लिए हम क्या पुट करेंगे फॉर एवरी x वैल्यू. ओके, so here we use the equation y का इक्वेशन क्या है, y equal to mx plus c, so mxi plus c bracket square. Okay, so here we substitute, here we just only substitute, here we substitute yi dash is equal to mxi plus c from equation from linear equation y equal to mx plus c. Okay. Okay, so here we get the equation. So here in this equation the yi is our actual value and yi dash is our predicted value. Okay. So we square the error and find the mean. So here the name mean squared error. Now that we have defined a loss function, so let us get into the interesting part, that is the minimizing it and finding the m and c. Okay. So here we are finding the loss function by using the substituting the value of yi dash. Okay. So this is the linear equation and the loss function. Here we get the loss function. So the next part is what is mean by gradient descent. Okay. So first is what is gradient. So gradient measure how much the output of a function changes if we change the input a little bit. So the gradient simply measures the changes in all the weights with regard to the changes in the error. So we can also think of a gradient as the slope of the function. So higher the gradient, then the steeper the slope and the faster a model can learn. So but if the slope is zero, so in that case the model stops learning. So in the mathematical terms, a gradient is a partial derivation with respect to its input. Okay. So in machine learning, the gradient is what? It is a derivation of a function that has more than one input variable known as the slope of a function in a mathematical term. So gradient simply measures the change in all the weights with regard to the change in a error. So gradient descent is an optimization algorithm to find the minimum of a function. That is optimizing algorithm for finding a local minimum of a differentiable functions. So gradient descent is simply used in the machine learning to find the value of a function parameters coefficients that minimize a cost function as far as possible. So here, so this is a simple gradient descent algorithm. Let us understand here. So the gradient descent is our iterative optimization algorithm to find out the minimum of a function. Okay. So here we use the loss function. So imagine a valley and a person with no sense of direction who wants to get the bottom of the valley. Okay, so he goes down the slopes and takes the last step when the slope is a steep, and the small steps when the slope is a less steep. Okay, so the person decides his next position based on his current position and stops when he gets to the bottom of the valley, which was his goal. Okay, so if the steep slope value of d is a high, so take a large step, and slope is a less steep value of a d is a low to take a small steps. Okay, and this is a goal. Goal is what here? The bottom of the valley is a goal of this person. Okay, so let us try to apply the gradient descent to M and C and approach it step by step. So here initially let M is equal to 0 and C is equal to 0. So and L is our learning rate. Okay. So this control how much the value of M changes with respect to the with each step. Okay. So L could be the small value like 0.001 for a good accuracy. Okay. जितनी L की वैल्यू कम होगी उतनी हमें क्या मिलेगी accuracy ज़्यादा मिलेगी. Okay. So if the value of L is too high, then the gradient descent won't reach to the minimum minimum point. Okay, and if the value of L is too small, then we take a lot of iteration to get the accurate value. Okay, so the next step is what? The calculate the partial derivation of the loss function with respect to m and plug in the current value of x, y, m and c in it to obtain the derivative value d. Okay. So here, finding the partial derivation with respect to simply means that differentiate the function only the term that containing m and consider the everything is constant and plug in the current value of x, y and m and c, okay, to the obtained derivative value of d. So here the mx plus c is predicted value, that is a y bar. Okay, जैसे हमने ऑलरेडी डिस्कस किया था ये वाले एग्जांपल में y बार डैश को हमने क्या किया mx plus c प्रेडिक्ट किया है. तो यहाँ पे देखो सेम इक्वेशन है 1 डिवाइडेड बाय इन समेशन ऑफ I इक्वल टू 0 to n yi minus mx plus c, okay, minus xi. So, okay, so this is our dm. So dm is a derivative with respect to m. So here the dm is value of the partial derivation with respect to m. Similarly, let's find the partial derivation with respect to c, that is dc. Okay, so dc के लिए कैसे होगा इक्वेशन? -2/n. Similarly, for the dc also, summation of I equal to 0 to n xi नहीं होगा yi minus yi bar. Okay.
If I'm having like B reverse, that means क्या होगा अगर मेरे पास A है तो next अगर क्या आएगा A आएगा, AB है तो B A आएगा, right ना? First
So
होगा
the equation for DC.
Right? So first A से अगर start करते हैं A on model, we will get a A on A, we will get a A on B, we will get a B A sorry.
हमें क्या करना है डीसी का इक्वेशन फाइंड आउट करना है. सो जिसके अंदर डीएम क्या है हमारा डेरिवेशन विद रिस्पेक्ट टू एम और सी के लिए हमें क्या करना है. ओके, सी क्या होगा ओनली वाई इंटरसेप्ट वैल्यू होगी ना. सो यहाँ पे क्या होगा डीसी is what over -2/n summation of I equal to 0 to n. We have yi minus yi bar. Okay, so this is a derivation with respect to c.
तो ए को मींस ए बी को मैंने रिप्लेस किया तो मेरे पास ए बी ही वापस आएगा. क्लियर? अगर मेरे पास बी बी था तो बी बी को रिप्लेस करने के बाद वापस से बी बी ही आएगा क्योंकि मैं.
Okay, so these are the two steps.
That is my lambda transition. That means nothing will be replacing there. I'm just popping out the element.
The step 3 is what? The step 3 is now we update the current value of m and c using the following equation. जो भी करंट वैल्यू होगी m एंड c की प्रीवियसली कितनी थी m इक्वल टू 0 c इक्वल टू 0. सो उसको अपडेट करके कुछ वैल्यू हमें मिलेगी. ओके, नेक्स्ट इटरेशन के अंदर. तो हमें क्या करना है वो वाली जो m की वैल्यू थी उसको अपडेट करना है. सो बाय यूजिंग दिस फॉर्मूला वी कैन अपडेट द वैल्यू ऑफ m एंड c. ओके, सो हियर l इज द लर्निंग रेट and learning rate, so at each update the accuracy increases and they get closer our goal. Okay, similarly to C also, यहाँ पे m minus l into DTM की वैल्यू हमें मिली है, लर्निंग रेट की वैल्यू होगी और उससे हम क्या कर सकते हैं m को अपडेट कर सकते हैं. Similarly for C also. So the step 4 is what? So we repeat the process until our loss function is a very small value or ideally 0, which means 0 error or 100% accuracy. So the value of m and c that we are left with now will be the optimal value. जो भी हमें value of m and c मिलेगी after we are left with now, so it will be the optimum value where we get the 0 errors and the 100% accuracy. Okay, so see here in this example So, in this analogy, the m can be the considered the current position of the person, and d is equivalent to the steepness of the slope, and L can be the speed with which he moves. Okay. So now the new value of m that we calculate using this equation. So here the next position is what, our L into D. Okay. Next position is what, our L into dm, or L into dc. So the next step is L into D will be the size of the steps we take. When the slope is a more steep, that is D is more, so he takes the longer steps, and when it is a less step, so D is a less. Okay, so he takes the smaller step. Okay, so the D is more means what, slope is a more steep. So in these cases, the longer step we use. Or when it is a less step, that is D is a less अगर होता है, so he takes the smaller steps. Okay, so finally he arrives the bottom of the valley, which correspond to the our loss equal to 0. Okay, so now within the optimum value of M and C, our model is ready to make a predictions. Okay, so see here, in the implementation of the model, the step one is what, we will take the data and pre-process it. Okay, and step two is what, build the model, and step three is make the predictions. Okay, so this is our first data set, and after predicting we get this line of best fit by using the gradient descent algorithm. Okay, so here in the gradient descent, it is the one of the simplest and widely used algorithm in a machine learning. Okay, so इसका implementation भी है, इसको हम implement कर सकते हैं पाइथन के अंदर. So पाइथन के अंदर फर्स्ट पार्ट क्या होगा हमारा, डेटा सेट कंसिडर करने हैं हमें, x मीन्स ओवर इंडिपेंडेंट वेरिएबल, y हमारे डिपेंडेंट वेरिएबल. सो हमें क्या करना है, बिल्ड करना है मॉडल. ओके, सो हम बिल्ड करेंगे उसको एंड देन द मेक द प्रेडिक्शन. सो बाय यूजिंग दिस formulas we can make the predictions. Okay, so this is the gradient descent algorithm. So in the machine learning, this gradient descent algorithm been used because it can be applied to any function to optimize it. Okay, so learning it lays in the foundation of machine learning. Okay, thank you.